Hello everyone, welcome to this session this morning. My name is Tyler and I'm chairing today. Our first speaker is David Eyers with the talk on Indigenous data sovereignty checks and permissions for code repositories. Just as David comes up, just a note to our speakers and our timing, I've got two stickers. Green will be your 5-minute warning, red is your 2-minute warning, and if I stand up that means you're out of time. With that, I'd like to welcome up David.
Righto, so I think today's talk, I've got no shortage of material, so I think those sticky notes are going to come in handy, and you can throw things at me when it all goes completely over time. The talk which I'm giving today is entitled Indigenous Data Sovereignty Checks and Permissions for Code Repositories, but I really need to do some expectation management. These are very initial thoughts about these topics. I'm not going to be providing a silver bullet, so to speak. It's probably not the nicest sounding terminology. There isn't a silver bullet, but I really just want to start a journey, and that's sort of my priority for today. And like I said, I hope that we get discussion from this, and I really want this journey to be collaborative as much as we can move forwards with that. So what's my motivation? The aim here is to kind of get a reality check on mechanisms that can enrich software code repositories with metadata to help support data sovereignty. It's true that the origin of this question for me is coming from the perspective of Maori data sovereignty and Indigenous data sovereignty, but I'm kind of really buried in the technical levels here where I am trying to open up this journey that would help facilitate changes that would help lots of different groups, including Maori and other Indigenous support for this kind of data sovereignty that I think we need. The disclaimer, as I put here very clearly, I'm absolutely not claiming that I've got some particular authority in this area. I'm really just trying to move us from the situation where I think at the moment there's a lot of missing pieces in the puzzle entirely, and it's useful to look at trajectories to even start the journeys to try to fill in some of those gaps. This is not yet a co-design process, so I would make that clear in terms of where we currently stand. The initial idea, I was chatting to Maori researchers in another project that I'm involved with, and we were discussing in the break that part of the problem, I think, at the moment with the way that the sort of funding model works for research in New Zealand, I was comfortable having these sorts of discussions and ideas come out of a complete side aspect of a different project. And so ideally, we would have funded these discussions first and foremost, but I think, at least for the moment, I'm going to go with the fact that a side effect of a different project has opened up this interesting path to investigate. So I'm going to talk about some straightforward techniques that might work here, but I want the reality check from the room as to where we're going to go. The project I mentioned where this idea came out of, and I said it's a very small idea, I don't want to kind of get the hopes up too much in terms of the scale here, but the project was a SIFTI, a National Science Challenge funded project called the Veracity Spearhead, and it has been investigating provenance. It's been investigating provenance particularly in supply chain systems, and one of the areas where there has been some really interesting output from a technological perspective is looking at software bill of materials and supply chains that fit within software systems, which is definitely a rapidly emerging kind of area. But because we're looking at provenance tracking as part of this work, and as I've indicated here, provenance, what I'm sort of talking about is the origin, history, and authenticity of data, where it's come from and where it's going and what you know about it. It came up in our discussions that some of the software that we were using, that we were developing ourselves, were sitting in code repositories that we realized, of course, didn't actually have any way that we could see to easily express the data sovereignty aspects that connected to the code itself. So the code that was inside the actual software repositories, which has led to this discussion today. So one type of software which I think at the moment is reasonably lacking in terms of data sovereignty support are software systems for actually managing software. In other words, source code management systems themselves. And so I'm seeking to start the journey to see what we can do to kind of try to plug that gap. So source code management examples, and I think most people in the room are going to be very familiar with this, so apologies where I'm sort of going over topics that you already understand. You can kind of pause and consider all of the other stimulating discussions that have happened today, and then come back to me when we're talking about the more specific content from this talk. Generally, software source code is going to be handled as a tree of files and folders, and source code for programming languages is usually stored in text files. There's a whole bunch of other binary files you might have in your repositories. If you want icons and things like that, there'll be image files. When I say SCM, that's the source code management software. They kind of wrap up this folder tree and files and everything and then allow it to be manageable over time as this software develops. And I think, hopefully I won't offend too many people by saying that Git has become the dominant SCM tool. That's just sort of emerged over time. And a couple of call-outs here. First, a call-out to the Carpentries for providing excellent training on use of Git in the context of research. So definitely, if you're not already up to if you're not comfortable with that tool, then I'd recommend the Carpentries lessons and workshops for becoming comfortable, and also a call out to NeSI for having supported the Carpentries in that mission, particularly within New Zealand. What I'm interested here, though, are source code management systems that have been elevated to be on the web, and that's the difference between Git as the technology that's actually managing the files and folders, and say GitHub, which is one of those platforms that's placed on the web. So lots of large-scale web-based SCM tools that are available. GitHub is probably the most well understood and sort of widespread one. I'd also call out a couple of others, GitLab and Bitbucket. From large software providers. All three of those ones do have ways that you can pay to have, well, actually GitLab is open source, but the other ones have mechanisms you can pay for if you want to have local serving of this infrastructure, so you do have an option to choose between the cloud and something which is local to your organization. But there's a ton of others. Basically, source code management systems seem to be one of those rites of passage for programmers who have a favorite programming language, that they'll see this tool and go, that's not in my favorite programming language, so I'm going to make another one that's in my favorite programming language, and away you go. I've just picked two because they happen to sit in languages which I've been floating past recently, but again, no offense is intended by this selection of these sorts of tools. There's a ton of them, and we'll come back to the sort of mechanisms I'm talking about, why it matters that we need to be thinking about these sort of web-based tools. So over time, there's sort of been this de facto emergence of repository metadata that sits typically within Git repositories. And if you've dealt with software in that form, you will have come across this and you'll be familiar with it, but I don't know how much you've explicitly thought about it, and that's what I'm trying to prompt here. What you typically have is metadata that's included in the repository is often done in a simple way, which is that you plonk it into text files and it sits in the repository along with your source code. So that then goes into two different paths. You have some of those metadata systems that are designed to be digested by software systems themselves, and others that are designed to be largely digested by humans who are looking at this kind of code repository. So that's kind of the split that I've made here is the repository data that's about people and the one which is sort of focused on managing the repository itself. A simple example would be there's a git ignore file which tells the Git system which files not to bother trying to track when it's actually looking at doing version management, and a whole bunch of things that can do these sorts of automated pipeline systems for doing data processing, more fancy. That continuous integration specification also typically sits in those kinds of files. When you've got the ones which are human-focused, here's just a list of some of the ones which I've certainly come across in my travels. The README is the starting point, which you'll normally expect to come across now. It's one of the things we now, when we're teaching students to do their source code repositories, it's kind of like, you know, we don't want to be negatively marking, but we're sort of saying definitely there should be a README file. You need to get people some sort of human context as to what's going on as a starting point. But there's a ton of others, and you see license or copying relate to legal licenses of code. Sort of interesting that it's still only contained in text files within repositories. I guess that I'm not a lawyer, so I can't talk about how embedded it needs to be in the software to work in different ways. There's a ton of others, as I said, like contributing, which talks about how you can join in these projects, the code of conduct, what's expected of the actual community doing software development, authors and contributors, which is usually making a reference to people who aren't explicitly committing code to your repository, but they've been important in some way in terms of allowing you to get where you are. Credits, which is a similar type of point, and then some others which are about style guide, is managing what kind of presentation you expect in the repository, frequently asked questions, or roadmap, which is talking about where you go next. When you see this in terms of something like a GitHub repository page, and again, you don't need to see the actual text that's on this repository page, it's a repository for one of these web-based Git repository systems. What you see here is you've got a starting web page of the type you might see on one of these web-based source code management systems. You see the files and folders in the repository that are listed. What you notice as well these days, I've highlighted in the top circle there, there's some extracted metadata that's actually come from that repository that the source code management system is noticing. So it's actually told you there is a README, and it makes it easy to navigate to it, and that it's actually under an Apache 2 license in this particular case. So it's looked in the text files for the metadata and extracted that from the web-based source code management system. So those are the examples which I've kind of pulled out there. You also see that the README itself, that is actually this content from here down. So the README is being rendered graphically as part of the starting web page, which means you get this nicely knitted together system. But it's not standardized anywhere. This is an ad hoc sort of convention. And I mean, thinking to Carol's talk this morning, it's interesting to see where these conventions start sticking to actually enable something useful to happen. Because now the actual source code management system's own code is paying attention to this sort of ad hoc development of metadata. And that's sort of where I want to go with the data sovereignty discussion. That's if my laptop doesn't jump off the podium. That would be very exciting. It might interfere with the presentation a bit. So what about data sovereignty when it comes to kind of thinking about placing this kind of material under the eyes of source code management systems? I'd say at the moment that a lot of software doesn't respect data sovereignty simply because there's no way to express what you mean by data sovereignty in that context. So where we came to talking about this in the Veracity project was looking at some Git infrastructure we had that was going to end up cloning the repositories for resilience against technical failures that was going to leave New Zealand. And so that's an example where these Git repository servers were going to be throwing around this source code with no attention to the actual sovereignty of the material that was in there. So that was one of the places where we started talking about what mechanisms could we use to allow us to kind of improve the source code management software itself to understand what was kind of going on. Now, anecdotally, it's often okay for that kind of artifact to be shifted around, but the point is the discussion should be explicit. So you don't want to have this implicit idea that it's okay to kind of do replication in that particular way. So how can we record this information? Well, the ideas that were floating through my head, or our heads, I guess, collectively, does it make sense to be looking at trying to isolate in another one of these sort of ad hoc metadata forms an explicit indication of things related to data sovereignty? So I was toying with the idea of provenance or the idea of context. Does this make sense to kind of try to take out of your repository system and really highlight that particular aspect of the provenance of your data in that repository? So seeking a new human readable metadata file, I mean, there are arguments for and against, and I'm hoping that you can tell me what you think about this. There are other places you could put this, but it struck the discussions that I've had so far, README feels like a very generic place to be putting something that's actually relatively important to what you do with the whole management of that repository. License, well, sure, the license is very important, but it's legal, and in some sense that doesn't feel like it fits quite either. There's sometimes when the actual legal license makes perfect sense to be the place to put in sovereignty restrictions. There are other cases where it just doesn't quite feel right because it's not modifying the legal agreement in the Western legal system presentation that the license files normally take on. Certainly these things were not designed, I think, with a huge amount of attention to the sort of, well, certainly Indigenous perspectives. I suspect these licenses predate a lot of the work in that space. So what we then have is this kind of, whatever we do, we want to have this kind of unambiguous content, and this is one of the things where I'll just make a call out to local contexts work in this space, because I've been discussing, just again, very initially with local context developers, where we might work here and embedding ideas like the traditional knowledge labels or local contexts do the traditional knowledge labels, and also they have the BC labels as well, but for me, I'm probably focusing on the TK labels. I just don't want to kind of leave out the other work. I'm not, again, an authority here, but Maui Hudson is. He's talked about TK and BC labels at previous New Zealand eResearch events, like last year's keynote. That says 5. That's okay. I think we're still under control. More or less. So the point here is that the traditional knowledge labels, what they allow is discussing metadata to attach digital records of Indigenous cultural heritage, and as listed here, can facilitate attribution, describe access, indicate appropriate use, which is where we're probably interested on the data sovereignty side, and describe how to become, how involved the communities have actually given consent when it comes to a given sort of project. How you apply these labels is quite orthogonal to the definition of them, and the really nice thing about the local context work is that they have these standard templates for what labels might involve, but then you customize them for your particular context. So when it comes to applying TK labels in source code, there's clearly a lot of different ways we could try to do this, when talking to local context developers so far, they've said, I mean, they're keen to investigate this, but a strong need hasn't arisen yet in terms of an actual need for this, but I don't mind trying to preempt that. So in terms of mechanisms, we can include references to TK labels within metadata files. And again, the problems here, it's not a kind of panacea because you still have these problems that what is the granularity of what you're actually trying to label? If you look at the actual underlying data model of something like a Git repository, it's quite rich as to what you could actually connect to in terms of the objects in the repository itself. So you've got a fairly blunt tool when you're dealing with a text file that kind of describes some metadata about the repository, certainly better than nothing. But so the idea I've been floating so far is whether or not those sorts of either a special new one of these metadata files, or even if you just implant it in README, you kind of can look at having reference to unique URLs. Essentially, this is a linked data kind of approach to descriptions that connect to TK labels. One of the questions which is now emerging with that, apart from the difficulty of the granularity, is also where does this fit in terms of the interpretation of these data sets? Recently, things like, I don't mean, I'm not picking on OpenAI specifically, but generally tools that are training on large AI, the AI models that are training on large data sets, it's a bit questionable as to whether or not that input data has really paid attention to all the different ways in which licensing ideas have been expressed in terms of use of that code. For example, the code pilot type things where you may have open source, but actually there are extra conditions in the open source that mean it's questionable that you can train an AI model on it and allow that to keep moving forwards. So what mechanisms can we use? Badges are a way that you can describe in web SCM tools the situation of your kind of something that's happening to your code. Technically, they just load a remote image, and you can see here in this particular repository, there's a whole bunch of different badges that have been included there. What will typically happen is that they'll make reference to some external server that will then go look back at that repository and kind of see what it can scan from that repository and report some kind of status. So we have the tests are passing on the particular release that's occurring at the moment. So that's the status that's being reported. There are some great online services that can help you build these things. Thank you. And what I've sketched so far, which again is definitely not a solution, but it's just a very initial step, is again this kind of external service that can scan data from something like a provenance file or potentially from other of these metadata files and try to extract information that might, for example, have details like TK labels actually talking about aspect of data sovereignty in the code base itself. So it's of the actual code. So the example here, I mean, I just quickly hacked up something which I could shove on some free cloud resources somewhere to make work on GitHub. And this is one of those things which I remember from being enthusiastically technical when I was like a young kid. This is the moment where you're like, okay, that's red, that's green. And so I'd have supportive family members that would say, that's good, is it? It's like, yes, it's awesome. This shows that the whole thing worked, and like there's all this code behind there running in the cloud somewhere that makes it happen. But this is the type of thing that would be reasonably straightforward to do, is look at whether or not the status of the description of the metadata exists in terms of that actual repository. What I'd like to do in the time available is describe that what I'd really prefer, though, is going further than this and trying to get that same stickiness of the way which tools like GitHub have actually pulled metadata out and put it at the top level of these web-based SCM systems, look at actually extracting some aspects of data sovereignty that are understood by the SCM software itself. The reason for that, and it can work with the same sorts of mechanisms, you could read the information from what's being discussed, but what's key there is you can then integrate with SCM top-level features, like the way that the search works in the source code management, the way that directives to AI training, are we going to see a robots.txt kind of version of whether or not things should be allowed in AI models? But here, the data sovereignty specific thing that we'd probably look at stemming from the Veracity project would be saying, can we make sure that our actual Git repository servers are paying attention to this and make sure that data of certain types doesn't cross the national boundary in this case, because that's sort of one aspect in where we can support the sort of Indigenous data sovereignty concerns of that code. So in conclusion, and again, I'm hoping to open up to your views on whether this is a good idea at all or whether it's already been solved by someone else and somehow we've missed it, the plans for the future include wanting to actually incorporate real customized TK labels. Been a bit nervous about slapping TK labels as examples on my own slides because I don't actually have traditional knowledge integrated strongly into this presentation. I could put the sort of non-checked label on there, I guess. Also look at dealing with something which has more than kind of day zero support with respect to how these sorts of badges might be generated. And then really sink teeth into more of that source code management software extension work. So actually supporting extracting the metadata from these repositories that mean that the source code management itself can actually then behave in a way that's consistent with some of the specifications inside that metadata. So please feel free. I'd love to hear your views on this and anyone who is keen to join in, that would be great. My priority would sort of be to try to set off this trajectory and then stop making a mess and hand over to people who can do a better job of making this stick in a more permanent way. Thank you.
Are there any questions from the audience?
Yeah.
I have a question in terms of thinking about when we publish things to repositories, the other thing we can do is give them a DOI.
Yep.
And DOI, DataCite has a sort of rights metadata field, which includes, they've done some work with the traditional knowledge labels and local context.
Yep.
So I was wondering if there was something in there around what you could,
That's great.
a standardization of the way that you could do that, and then something that the likes of GitHub could pick up.
Perfect. Yeah, no, what I really like about that idea is I can see immediately that involves a little bit more crawling, but that means that one thing which is trying to look into the repository and discover whether there's the existence of descriptions of particular constraints could say, actually, I'm going to check if there's a code DOI. And if there is, I'm going to then go and crawl that and then go and check whether or not I'm seeing those rights attributions there. Because I'm aware that, I'm really floating here in that sort of ad hoc metadata space, and the DOI area is obviously not ad hoc metadata. Thank you. That's a really good. I'll invest. Definitely we'll follow that up. Yeah, what I particularly like is being able to merge the different sources of ideas there, which would be good too as a useful sort of aggregation service. Yeah.
Excellent.
Good, thank you.
Thank you very much, David. Please all join me in thanking David. And I would now like to invite up our next speaker. This is David Brownlie from REANNZ, presenting on the topic Applying a Technical Lens to the Growing Risks in Research Collaboration. Please welcome David.
Kia ora, I'm David. I am going to skip a couple of slides here. So I wanted to start with saying I'm not a researcher, but part of my day job means I get to talk to a bunch of researchers, so that's really cool. It's probably at least 20 years since I would have claimed to be a security expert as well, but I get to talk to a bunch of them too. So the talk's sort of been, okay, where'd that go? That's interesting, sorry. It's back again. I've sort of prepared my talk with not being an expert in either field in mind and made some assumptions that some of you may pick up on. I've also taken a really technology-oriented view in this. Basically, the assumption is that part of your collaboration is going to be moving data around and providing shared access to data. Everything I talk about today is publicly available, so there's nothing secret there. And I will focus on highlighting some risks. So you'll have security staff within your own institution. They're going to have far more specific information about your individual areas, about your institutions and what those risks mean to you. So this is very, very high level. What I'm going to start with, though, is that the New Zealand government released a national strategy in August last year, and one of the things that came out of that was highlighting that we actually do have an ongoing collective responsibility to try and start talking about this wherever possible and making it part of the conversation. That's something I completely agree with. We may all draw different conclusions when we talk about it, and we possibly should, but it's the conversation and the general awareness, I think, that's important. So one of the first bits that was really interesting to me in reading through that new strategy is that the acquisition of sensitive research from New Zealanders is called out in almost, I think it's the second paragraph, and also the targeting of academics by nefarious actors. And in fact, end of last week, there's an article out about the Russian Secret Service actually targeting UK academics and their email accounts, not because those academics are people they want data from, it's those people's contacts. So they want access to their email so that they can pretend to be somebody and then try and get access to information. Obviously, with all of that situation still going on, there was no information about what they were actually targeting. It's just the activity that's being talked about. But there are real risks out there that are going on, and it's not just in Europe. So this is from the 2022-23 NCSC, the National Cybersecurity Report. 316 incidents affecting nationally significant organisations. Those are only incidents that have actually reached the National Cybersecurity Centre. So we're not talking about all the incidents, just those ones that have reached them and are viewed as significant. 23% looking like they had foreign government involvement. So when we think of kids sitting at home trying to hack things, that's not what we're actually worried about anymore. A lot of these have got state backing and probably bigger IT teams than most of our institutions. So there's a lot of thought and a lot of money being spent in doing this. The other thing that is really interesting in that report is the increasing number of incidents targeted at supply chain. And the really scary one is one that was actually included in a legitimate software update for a VPN client. So you're getting malware downloaded in your official software update, which is really hard to sort of work around. Supply chain is becoming something that people are being encouraged to look at more and more, know where your software is sourced and who's actually delivering it to you. My background is as a network engineer, so we like models, we like to chunk things up. So I've thought about research and collaboration in terms of chunking it up into collection, transit, storage and analysis, just because in my brain that kind of makes it a little bit easier to look at some of the tools that are being implemented and some of the risks that we've been highlighted. So I'm going to start with data collection. Basically, and I've been lucky enough to sit on a sensor networking group that we've had across the sector and learned a lot more than I did a year ago about sensor networks and what's going on. And we also had some overseas people come in and talk about their experience. What we see is sensor networks becoming far more sophisticated. You're getting easily deployable and cost-effective computing that you can actually put out in the field. The problem is, once you've got a device with a CPU, there's a good chance it needs access to software updates, and it's going to have some form of connectivity to do that, otherwise it's kind of irrelevant. But once you've done that, you become vulnerable to unwanted access while you're actually collecting the data. And there's been a lot of talk already at the conference about AI. The link at the bottom there is something that the guys from the University of Oregon, I think it was, were talking about. NSF funded a $9 million project a couple of years ago to actually deploy AI out in the field in the sensors. So you're actually getting a lot of the AI happening actually out well beyond where you would traditionally think about your security domain of your institution. Now I'm just going to jump into something you may or may not be aware of what malware and phishing is. Malware is basically introducing software to a system for the purpose of doing harm. Phishing is what we were talking about before, trying to be pretending to be somebody to get a user to do something. Now that, in the media when we hear about it, often ends up being somebody wants money from you, so it's a financial thing. Those are the ones that end up in the media. There are many cases where people are doing this to actually just gain access to systems or access to information. REANNZ has recently actually worked to implement MFN and Fishing Disruption Service, which are services that come out of NCSC. It used to be CERT New Zealand. The website still says so, but they've been combined. So that we are blocking things in the core of the network. Now, the problem we have is that our routers only understand internet numbers. So once it's got to our router, the only thing it sees is a number. So if we get a number that's a known bad place to go to, we can drop that traffic. But if it's one of the other ones that's a URL or a location, that requires that to be implemented on DNS. We're in the process of doing that on our DNS servers, so if you're using our DNS servers, you get that protection as well. But the other thing is there's other networks in New Zealand that are rolling this out too. The REANNZ guys are up the back. They were called out by the Deputy Director of GCSB last year for implementing this across their mobile and broadband networks. And I think the highlight in the article was 75,000 hits in the first week that they had it in operation. So that there's lots of traffic out there, not just coming in. We've already seen a lot of it that's actually from impacted hosts being directed out of the country. So that's our machines trying to connect out and deliver information out of the country. So 3 different ways of doing it, obviously. You've got your IP addresses, which is what the routers understand. The 2 examples up the top there are actually ways that you can test whether the network you're currently using is being covered by these protections, as is the IP address actually. So the only weird thing about these test sites is you'll get that nice blue message if it's a fail, so you're not protected. If you are protected, the sites will just time out, so you get a blank screen and nothing happens, which is kind of a weird way to actually get a win out of it. But those links are up on the NCSC site, and you can go and actually verify what your service is doing. I've checked my home and mobile ones, obviously, and there's some really different results out there at the moment. The other thing I would mention is that the locations these are blocked are proven locations that you actually don't want anywhere near you. So they tend to err on the side of caution. There will still be bad things that are allowed through these lists because they haven't been proven to be, everything's bad. So they're only blocking what they absolutely know shouldn't be actually happening. So if we move to data in transit, moving data has become a lot easier. We've got a variety of different transport systems available, and then at the application layer, you've got architectures like ScienceDMZ, you've got tools like Globus and FileSender and a variety of proprietary systems that help data move very, very quickly. I'm going to avoid talking about the application stuff and actually dive down to the data transport technologies. So there's a list of them up there, and I won't go through them, but it's a huge list these days. The map on it's your right, everything in blue is stuff that is currently covered by Starlink. Now, I started off in the early 90s trying to get connectivity into dairy factories at 9,600 bytes, or bits per second. I would have loved a map like that because basically it was turn up at Telecom and be told no, or here's the price, and you couldn't take it to the business. The RBI Phase 2 and the Mobile Black Spots Fund is one that I've deliberately included up there because that got some form of connectivity to 99.8% of the population in New Zealand. So that was a fund designed to try and fill those gaps we have. Now, the fun thing for those people running sensor networks is it was focused on where the population is, which is not necessarily where your sensors are. But what we are seeing is a desire to try and solve those problems as well. because as you imagine, there's now not much left. The other thing that's really interesting is, yep, Starlink can cover a lot of space, but we've recently heard that they're actually capable of delivering 10 gigabits per second of symmetrical capability, and they've done that in Alaska. So that's actually running now. It's not theoretical. They're delivering connectivity into Alaska at 10 gig over a satellite, which again just blows my mind. However, if I can use a really, really simple analogy, and I'll apologise for it being oversimplified, how many of you ever leave the house and wonder whether you actually lock the door? Because I do it all the time. Your security and infrastructure teams are now thinking about 20 doors, 30 doors. As we add all of this technology, the problems that they're dealing with become more complex. Now that's okay, because we're getting more tools as well. I know personally I have moved to an Internet of Things solution where I get an alert if any doors are left unlocked or my doors are left open, because I've got teenagers and they leave everything unlocked and open. That is just a quick view, because fibre optic cables are still the way most of the data moves around the world. That's an NREANNZ view from a couple of years ago, so those are all the sort of cables we connect people to. The map of global submarine cables is massive compared to that. I looked at it, there's an updated one, there's so many cables on it, it almost doesn't make any sense anymore. But what we've done on those things, manners, which is a way of agreeing about how you prove what addresses you should be allowed to advertise to the world, has been implemented on REANNZ. We were actually the first in the Pacific to do it. Many networks following suit now. Basically, it's you can trust that an address that says it has data for you or you're sending to is who they say they are. So a few years ago, we had a few issues with people in South America advertising address ranges from people out of this community and pretending to be organisations they weren't. With manners properly implemented, if the whole internet did it, that becomes impossible. The other thing it does, and one of my colleagues pointed out, I'd forgotten to mention this, misconfigurations still happen, it stops that too, which is kind of nice. Distributed denial of service, you've probably all heard about things like the New Zealand Stock Exchange, the Waikato DHB, Parliament, they've all been impacted by this sort of thing. With new servers being able to be deployed in minutes in the cloud, unfortunately the people who are doing nasty things get to take advantage of that too. And what we're seeing is more of these adaptive attacks where the source of the attack moves as soon as you've figured out where it's coming from and blocked it. So it is getting harder and harder because they get to use AI-like technologies as well. What it means is we just have to keep moving, and the big issue you've got is it does take a few minutes to try and avoid having false positives, so some of that traffic is always going to get through. The other thing again that I'll reiterate, quick Google search for the image of DDoS brings you up a little guy with a little laptop. It's not that anymore. When you've got state-sponsored teams doing this, it's coming out of large data centres with huge resources. Data at rest. There's a bunch of things that can happen there. Phishing, social engineering, identity theft, email compromise, they're all ways of trying to get access to it. Ransomware, which is another one. NCSC has some ransomware advice up there. But the big thing there is email is often central to all of these services inside our organisations, and that's why it does get targeted. Data analysis. I'm not going to try and talk about supercompute security with the NeSI guys in the room because that would be ridiculous. What I will talk about though is AI again, because there is information now available on the NCSC site around AI and some of the risks it does introduce, but also some guidance on how to develop your systems to safely work with AI and to safely integrate with the way our security infrastructure is intending to deal with that. So they're well worth a read. Finally, we've had quite a bit of talk about the trusted research environments during the conference. the observations I'd make is that identity has been is critical to these environments in terms of, can you trust that the person who says that they should have access to something are actually who they say they are? I was lucky enough to be on an Internet 2 conference earlier in the year, late last year, where they talked about that being a $24 billion industry in 2024, because identity is becoming so critical to making sure that the right people are getting access to the right things. The other thing that has occurred to me after Wallace's talk yesterday was having these environments in one place does allow aggregated investment in infrastructure and potentially security, so that you're actually able to build them up and make them cheaper, but also more secure if they're all sitting in one place, should that be possible. So finally, just a couple of thoughts. Collective responsibility for the sector to make sure we're at least talking about this. There's lots of really helpful data on the NCSC site and other sites. There are increasing risks, but it's being balanced by increasing capability. There's lots of new things out there that we can implement, and the best way to actually deal with it is just to have an open conversation as a sector. Make sure you talk to your partners, your suppliers, your security teams, and just have the conversation. Some of these resources may help you be a little bit more informed about what you want to actually talk to them about. And I think I must have just about hit it.
Thank you. And while Nick here is setting up his laptop, it's my pleasure to introduce Nick with the talk Infrastructure for Growth of Research Talent and Skills. This is Nick Jones from NeSI.
Okay, kia ora tātou, ko Nick Jones, takawingwa, ko Nick David Jones, takawingwa. So I'm going to sit somewhere in the middle, as the David suggests, between the sort of the smart researchers that are doing amazing things around software and mātauranga Māori, and the network that's secure and dealing with a lot of complexity and keeping us all safe from ourselves and bad actors. So thanks for those talks, David and David. It's good to have the whakapapa well understood as you come into these situations. So NeSI, I'm going to talk a little bit about NeSI. Who is NeSI? These are the people of NeSI. There's quite a few of them here. There's a few in the room. I can see around the room, which is wonderful to see. About 44 people at full strength. We are a collaboration that sits across the research network. Primarily, we are based at 4 of the research institutions. So 2 universities, 2 government research labs, and with MB, who's in the room, wonderful to see you, as our core partner as well. We work across all of the areas of research where people might have a need for sort of computational resources and skills. We have a shared infrastructure which comes from investments made collaboratively with our partners, which we design, build and operate with them. We have a range of services which traditionally have been focused in on high-performance computing and the things that sit around that, including the skills, to really make the most of the resources we have available. These are the big computers. They're sitting over here at Greta Point here in Wellington, affectionately known as Mahuika and Maui, with a big row of storage in the middle. We've got some cores, we've got some GPUs, we've got some memory, we've got some more GPUs, some more memory, some disk, lots of bandwidth, more CPUs. There's lots of CPUs, lots of GPUs. So it's an environment that really can work at different scales and with different levels of performance for a really diverse range of workloads that hundreds and hundreds of researchers use every day to conduct their research in Aotearoa. The typical way that you'd sort of think about NeSI going back a way is on the right, on your left there. You log in through SSH to a command shell and a friendly little NeSI text logo pops up and greets you, which is wonderful. These days we've moved also though to through the browser using interactive notebooks like the Jupyter platform provides. And that really provides a through the browser experience of writing your code, putting illustrations in there, putting documentation in there. Probably we don't have TK labels and READMEs and all those sorts of things, I'm sorry, David, but hey, opportunity. We could roll it out nationally, let's do it. With RO crates, I hear. We have a range of data services. One of our core ones is based on the Globus platform. You all heard from Ian Foster yesterday, the founder of Globus. And so that's a platform that we've rolled out across the country. And as is often the case in our world, the Australians have copied us, which is wonderful. Well done, Australia. Not too late. You can still get there. Go, go, go. So we've got a range of endpoints across there, and that really provides a very optimised highway that really takes advantage of what we've got in the country with REANNZ to move data around the country, to move science data around the country in a very secure way, very accessible way. You can even access it by shared sort of web downloads and all sorts of things. We connect that into our HPCs, and I just heard from Ryan Chard. Is Ryan here somewhere? There he is at the back. So, hi Ryan. Ryan's from Globus. He lives in Kapiti Coast. Yay. So Ryan has built the sort of API access to compute services, HPC services in Globus, so Globus Compute, and it's a function-oriented computing model. So you can, I hope I'm getting that right. He's nodding, it's looking good. So you can really submit your workloads via API. So we've got the biggest user of that compute service in the world, in New Zealand, Chris Scott, who's not here. But that's because Chris has got it installed under his name, so he's taking credit for a lot of research. But it's wonderful to see the connectivity of these environments coming together. And there's a map of New Zealand, which is good. Mine's a different colour to David's. It says something different. It basically says these are where the data transfer nodes are around the country. Let's move on. I've got a lot of slides. I'm going to have to move faster. So one of the other platforms we have is our research cloud platform, our high-performance cloud platform. This is a platform we've invested in over the last couple of years, and it's an OpenStack-based platform based up at Tamaki, up in Auckland, and we deliver that in partnership with REANNZ and our technology partners, Hewlett-Packard, Stack HPC, NVIDIA, and Red Hat. This is an environment where we're looking to provide a range of services for different use cases within the sector. And we've tried to sort of capture those across the top. We do bare metal infrastructure hosting in this environment. We work very deeply with some institutions within institutional partnerships. And we also provide for research software engineers, or the researchers that know how to code and want to build environments. We provide a programmatic environment, what's commonly called these days an internal developer cloud. We provide that sort of developer cloud, developer platform for different institutions, different research communities around the country. How do we know it's good? Because we measure lots of things. We've got the gold standard, lots of case studies, which we can share with you, which typically explain how we have impact across a wide range of research areas. And they're a wonderful read. You read about the research, you read about the application of the technology into the research, a really wonderful output of the work that we do. And we also talk to researchers all the time, but we also survey them continuously. And down here, you can see our Net Promoter Score, which is remarkably high. And primarily it's high because we are a business that's based on customer intimacy. We sit there right at the front point of the relationship with the researcher, working with them day to day on their needs to use advanced computing. So while we have a support desk, if you talk to our team, they'll tell you it's just a channel for them to have conversations with researchers, and they spend a huge amount of time and energy sort of understanding researcher problems, getting their environments deployed into our various platforms, and then also lifting that up to skills training and into consultancy engagements where they're actually building and tuning and optimizing the codes that the researchers are dependent on to do their research. So some of those impactful partnerships that I've made reference to, you'll hear about this week, or you might have already heard about this week. You've heard, I think, yesterday from Jun and Claire talking about the collaborations that are existing now within this environment. And At the top left there, we've got the Taonga species genomic data repository. In the middle, Rakeora. This is a trusted research environment where we're in partnership with universities and government labs, but specifically in support of Ngāti Porou, one of our East Coast iwi, looking at the health and disease research that they need from a precision medicine perspective. So they've got their own community's data in this environment, and it's secured through a dynamic consent system, which means that they know exactly which researchers have access to the data, which workloads have been certified to run against the data, and it's only the code, the workflows, that actually can see the data. So a dynamic environment of consent, which when you talk to some of the kaumātua, the leaders of Maori health in the country, with a small tear in the corner of their eye, they say they've never seen this in the health system in New Zealand before. The ability to actually overcome the resistances to participate in health research that's specific to their communities and that depends on them sharing their taonga, their data, into these environments to get benefit that is reflected back directly for their need. So that's a wonderful project to be involved in. Another wonderful project to be involved in is the one that we're doing with eResearch on the top right there. So this is where we're building a custom eResearch infrastructure for their whole institution. And so it's covering all the bits of the puzzle, the data management, the HPC, the virtual environments, the identity management, all of those sorts of things to enable their eResearch strategy, the eResearch platform strategy. I mentioned the work our software engineers do, our research software engineers, our data science people. They collaborate very deeply with all of these researchers on the sort of workflows and tools, and those researchers are coming from a very wide range of disciplines, funded through all sorts of funding streams and mechanisms, both private and public. And we do spend a lot of time as a participant in the research sector, particularly when we get into some of our training activities. And it's wonderful to see people like Tyler and Murray and others here who are so critical to that sort of skill and capability building work that goes on here locally in Aotearoa. We work with a lot of partners supporting research across a full range of organisations. So, NeSI's turning 13 this year. Woohoo! I think we had our first eResearch, it was at your place, Mick, down in Dunedin. Our first eResearch. NeSI's first eResearch, not the first eResearch, yeah. Our first eResearch was in Dunedin. It's not often that I'm right and Mick's wrong, so I'll take that. So what's going on for us as we turn 13? A couple of years ago now, 18 months ago, we received a report around eResearch. It's the Sherwin report, Murray Sherwin, who's the inaugural chair of the Productivity Commission, which I believe is going to disappear soon, unfortunately. Advocated for significant additional investment in a broader scope of eResearch, infrastructure, capabilities, skills in the country, and really a shift to embrace what we're hearing a lot about this week, which is the needs that we all have around research data, and to put everything on a more sustainable footing. We worked with MB over the last year very closely, Amber and the REANNZ team and myself and NeSI, to look at what should come from that, and a data and digital research institute was the proposal. And so that was a business case that was developed. It's now sitting within MB and at the discretion of the incoming government and minister, and we're looking forward to hearing a little bit more from the minister as she comes to understand some of the details of policy work in this area. Meanwhile, we're getting on with getting on, and one of the key things we're doing at the moment is a platform reorientation, a refresh of infrastructure, and a big migration or rebasing of our work. We're faced within the research sector with a lot of cost pressures. I think everyone's probably aware of that if you're reading the papers at all or going to Wallace's talk. We've got a really wide variety of maturity and sustainability of eResearch capabilities and practices across the sector. We are developing and evolving our roadmap of products and services and capabilities in response to and in deep partnerships, as you've seen, with a range of parties across the sector. But what we do know is there's definitely a broadening level of uptake, which increases the diversity of research that we're supporting, and the diversity of need drives a need for a richer array of services, and really shifts our posture. It shifts into a much more of a shared collective responsibility model. There's changes going on. We've got Michael Karish here, who's our Chief Information Security Officer, and as a CISO, it's a new capability for us, Michael, to have someone looking at backstage at what we're doing. And he's lovely, he's very gentle with us, and there's a lot of work to do. But this is the world that we now all live within. So at the moment, through our investments, we're looking at a major refresh to our platform. There's some comments I've made in there, and I think just riffing on some of the themes that are going on at the conference. We do rely very heavily on open source software, and one of the key aspects of this repositioning for us is that most of that software these days is actually created in the public cloud. And that wasn't the case, that hasn't been the case for the 30 or 40 years of history of high performance computing. We've been the innovators. And so this is a very different posture, and we're having to change our whole approach to how our organisation thinks about where we even look for technology. We typically, historically, would have had a filter that said, okay, let's go looking for a solution. Okay, what are other universities or government labs doing? And we've really had to take those blinkers off and say, what's going on globally? Because the leadership in this space has shifted. And our opportunity is to really take advantage of the value that's been created very broadly now across all these ecosystems. Move a little faster. I think you've seen that diagram already. So look, I want to announce in a soft announcement today, there'll be press releases and other things later, but we have agreed we've been out to market for our infrastructure refresh, and we've got our selection of partners in place. And so I just want to acknowledge Xenon, Versity, Weka, Dell, and Sempre and Hewlett-Packard Enterprise. It's wonderful to have you all at the table, and we're really looking forward to what it might mean in this broad partnership in terms of how we can power the future of eResearch and computational and AI research in the country. Our partners are equally happy to be here, and many of them actually are here, so please do stop by and have a chat to them. We haven't made the big press releases, but we're quite comfortable talking about what we're doing and what's on the table in terms of the solution space that we're working in. So we're shifting our infrastructure into that Tamaki-based flexible HPC cloud. We're bringing in new capacity when it comes into the compute space and into the high-performance storage. We're bringing in new capacity on the cloud. And we're bringing in a new archive solution, which is a really big deal for those who've ever tried to use our current one. It's pretty broke. We're not going to fix it. We've tried. Versity is going to save us. Thank God. We're also not throwing away the past. We've got a huge amount of value, both in the skills and the capabilities we've got, and some of the existing infrastructure remains fit for purpose as well. And so as we migrate across, we'll be bringing across a range of our existing systems and integrating them into this new platform that we're building. It will be a richer platform. We will not just be having the sort of HPC and HPC plus notebooks. We're integrating ourselves into that cloud environment, the research, the flexible HPC cloud. alongside things like our research developer platform. We're shifting, as we do this, to as code, infrastructure as code approaches. And so we're really changing our practices as a team to really embrace cloud native, not only technologies, but methods and approaches as well, skills. And we think that that's actually going to be the future, not only for us, but for researchers as well. So we have to have a chat about our training programs and see what sort of skills might be useful to share with our research colleagues. Increasingly, we're looking at how we do this in partnership across the sector in a much deeper way than we have in the past, whether it's with the Research Developer Cloud to enable organisations' research teams, or sharing of infrastructure through co-hosting and service layers on top, or whatever it is that might be the right solution for a particular organisation, institution or community. So, skipping slides, I wanted to just make a final sort of plea. When we thought about eResearch in 2010, it was quite a simplistic view. We had networks and storage and some software, and maybe we had identity management, and we saw so many slides that looked like that. It's interesting, I've been working over the last year, over the last 13 years, and then over the last year, with a global community looking at what are the common things that you need to establish one of these sort of platforms for modern day science. And this is the Global Open Research Commons, and we've established through a collaborative endeavour across the globe the best sort of experience and insights have come together to build a model of what is it that we need in these sorts of platforms. And unsurprisingly, we do a bunch of the stuff in NeSI, but really it is a bit of a fruit salad. You can pick and choose which elements you focus on depending on your need. So the question for us is really, how do we meet our eResearch needs? And it turns out there's a whole lot of ways that we could think about doing that. Do we do it independently and so focus just on our local needs, or collectively? What are the benefits of doing it locally or nationally? Can we be more responsive and innovative by doing it locally, or can we get critical mass and innovation that way by going nationally? Is it just a light touch we need, just get out of the way and let sort of brokerage be the model, or do we actually need the domain expertise and the deep knowledge in these technologies to really make them, to really enable the research? Is it the big stuff that really counts? What about that breadth of need? How are we really going to support that diversity of research? So we think that partnerships are fundamental to this. Wherever you lie on those spectrum, each of those questions and many others, partnerships ultimately will help us all navigate. And not sharing the information in a small system like this isn't going to help anyone. So we're really looking forward to very hybrid approaches to organising in the future. So it's not just about big HPC centralised in one place. It's about really mixing and mingling with the communities and institutions that are out there, really trying to understand the needs and opportunities that come from that, and then figuring out how we can follow down those paths together. So thank you to the NeSI team, and huge thanks to our collaborators, to MB, our research reference group and our wonderful board of directors, our training partners across the sector, Genomics Aotearoa for being awesome. You guys are awesome. And the wonderful team at REANNZ. We've got amazing supply partners here, many of whom are in the room, and just to all the amazing researchers out there that we work with every day. Ngā mihi nui. Thank you.
Thanks very much, Nick. Are there any questions from the audience? No, I suppose that's the difficulty being before lunch.
Indeed, yeah. Thanks, Taylor.
All right, thank you. Please join me in thanking Nick.